This is a video from the Chapter 6 review. The directions say to sketch the region enclosed by the curves and find the area. So in problem number 1, we have y equals the absolute value of x and y equals 1 minus 2x squared. And so what I want to do is I want to draw a picture of these two curves. So here's the y-axis. Here's the x-axis, okay? And y equals the absolute value of x is going to look something like this. So when x is 0, y is 0. When x is 1, y is 1. And so we get a line going this way, or half a line, right? And then when x is negative 1, the absolute value of negative 1 is 1. And so we get a line, or I'll say half a line that goes this way. So notice how that looks like a V, right? And y equals 1 minus 2x squared represents a parabola. So we have a vertex at 0, 1, and it's going to go like so, roughly speaking, right? Now, recall the definition of the absolute value of x. So I'll put it down here. The absolute value of x is x so long as x is greater than or equal to 0. It's negative x as long as x is less than 0. And so I want to find out where the parabola and the absolute value of x intersect. But when x is greater than or equal to 0, the absolute value of x is x. And so what I'm going to do is I'm going to set x equal to 1 minus 2x squared. But that says 2x squared plus x minus 1 is 0. If I factor, I get 2x minus 1 times x plus 1 is 0, which says x is a half or x is negative 1. But remember the condition on the absolute value of x. Absolute value of x is x whenever x is greater than or equal to 0. And so the only value of x that makes sense is for x equal to a half. X equal negative 1 doesn't make sense because we're on the right side of the y-axis. Now, that takes care of this value of x here. Now, I'm going to set negative x equal to 1 minus 2x squared, which says 2x squared minus x minus 1 is 0. Factoring, we get 2x plus 1 is times x minus 1 is 0. So x is negative a half or x is 1. But x equal 1 doesn't make sense because this time we're on the left side of the y-axis. So x is negative. And so here x is negative a half. Okay, so if we draw a sample rectangle to the right side, we have two different regions. Okay, and then we're going to draw a sample rectangle to the left side of the y-axis. So I'm going to calculate A1 first. That's the integral from 0 to 1 of the top function, which is 1 minus 2x squared, minus the bottom function, which is x. Why? Because x is greater than or equal to 0. And I'm going to integrate with respect to x. So that's x minus 2/3 x cubed minus 1/2 x squared. And I'm evaluating from 0 to a half. If I replace x with a half, I get 1/2 minus 2/3 of 1/2 cubed minus 1/2 of 1/2 squared. And then when I replace x with 0, I get 0. So I subtract 0. So this is 1/2 minus 2/3 times 1/8 minus 1/8. And if I do a little arithmetic here, I get 7 over 24. Now, to calculate A2, I'm going to integrate from negative 1/2 to 0 of 1 minus 2x squared minus a negative x dx. But same game, I'm going to take x minus 2/3 x cubed plus 1/2 x squared, and I'm going to evaluate from negative 1/2 to 0. Plug 0 in for x, I get 0. Plug negative 1/2 in for x, I get negative 1/2 minus 2/3 of negative 1/2 cubed plus 1/2 of negative 1/2 squared. And so when I solve, I get 7/24. And that's how we find A2. And so the total area will be A1 plus A2, which is 7/24 plus 7/24. And when I reduce this, I get 7/12. And that's how we do problem number 1. Let's take a look at problem 2. Suppose x plus y is 0, and then x equals y squared plus 3y. Now here, if I solve for y, I get y equals negative x. So it's real important to draw a picture of what's going on. So here's the y-axis. Here's the x-axis right here. Okay. Now, y equals negative x. That's going to look like a line going this way. Now, when y is 0, x is 0. When y is, we can say y is 1, x is 4. So I'm going to go over 4, 2, 3, 4, and I'm going to go up 1, right? So x is 4 when y is 1. Okay. And now let's try y is negative 1. So when y is negative 1, I'm going to get x equals 1 minus 3, which is negative 2. So x is negative 2. So I'm going to go over 2, and I'm going to go down 1 right here. So far. And when y is negative 4, so I'll explain how I know that shortly. When y is negative 4, so let me write that down. When y is negative 4, x is going to be 16 minus 12, which is 4. So notice how I got x is 4 again. But I'm going to go down 4. 1, 2, 3, 4. And so it's a really interesting, it's a parabola that's going this way. Okay. Now, I can extend that a little bit, and we want to find the area of this region here. It's not a perfect parabola, but, And so I would submit to you that it is easier to draw a rectangle that looks horizontal. Because notice, no matter where I'm at, I have one rectangle and one rectangle only. And notice how the rightmost function is over here. The leftmost function is over here, right? So, by the way, if I solve for x, I get x equal negative y. Now, why did I do that? Because over here, notice that x is already in terms of y. Do you agree? Right? So now, I'm going to set negative y equal to y squared plus 3y. So 0 equals y squared plus 4y. So y times y plus 4 equals 0. So y is 0, or y ends up being negative 4. So the area, so this is an integral with respect to y. So I'm going to go from negative 4 up to 0, right? So I'm going to go from negative 4, so this is negative 4 up to 0. And I'm going to take the right function, which is negative y. So I'm going to take negative y, and I'm going to subtract y squared plus 3y. And I'm going to integrate with respect to y. So let's see if we can finish this. So this is the integral from negative 4 to 0 of negative y minus y squared minus 3y dy. Now, if you guys are okay, can I factor out the negative 1? So in other words, I'm going to write this as, I'm going to factor out the negative 1. And I'm going to integrate from negative 4 to 0 of, and then it's going to be y squared plus 4y dy. So this is negative of 1/3 y cubed plus 2y squared, evaluated from negative 4 to 0. If I plug in 0, I get 0. If I plug in negative 4, I get minus a negative. If you don't mind, when I plug in 0, I get 0. And then I'm going to subtract a negative. Can we see that that's going to turn positive? So I'm going to put a plus, right? And then when I replace y with negative 4, I get negative 64 over 3. I'm going to go plus. And then if I square negative 4, I get 16. 16 times 2 is 32. And the correct answer here is going to be 32/3. And that's how we do problem number 2. Let's take a look at problem number 3. So we have y equals the square root of x minus 1. And we have x minus y equals 1. Okay. We got to draw a picture. It's very important we draw a picture of what's going on. Okay? So here's the y-axis. Here's the x-axis. Now, when x is 1, y is 0. When x is 2, y is 1. And so we get a graph that looks roughly like this. That's the first curve. So this curve here is y equals the square root of x minus 1. When y is 0, okay, x is 1. That's here, coincidentally. When y is 1, x is 2. Is that okay? So interestingly, that's here. And so if I were to draw, it's real small, right? But we're going to get something that looks like this. Like so. So this is x minus y equals 1. So again, when y is 1, x is 2. So 2, 1. When y is so when y is 0, x is 1. That's here. Okay. Now, notice how the first equation, y is a function of x. So it would behoove me to solve for y in terms of x. And when I do, I get y equals x minus 1. And I still want to find and make sure the points of intersection are what I think they are, right? And so what I'm going to do is I'm going to set the square root of x minus 1 equal to x minus 1. If I square both sides, I get x minus 1 is x minus 1 squared, right? So when I solve, I get x minus 1 is x squared minus 2x plus 1, right? So 0 equals x squared minus 3x plus 2. So when I solve, I get x minus 1 times x minus 2 equal to 0. So x is 1 or x is 2. And does that match? So here's x is 1, here's x is 2. So it looks like it matches. Notice how the top function is square root of x minus 1. The bottom function is x minus 1. So when I set up my area, I'm going to integrate from 1 to 2, right? Now, what's the integrand? I'm going to take square root of x minus 1 and I'm going to subtract off x minus 1. I'm going to integrate with respect to x. So this is 2/3 of x minus 1 to the 3 halves minus, if you don't mind, I'm going to say 1/2 of x minus 1 to the 2nd. And I'm going to evaluate from 1 to 2. If I plug in 2, I get 2/3 minus 1/2. If I plug in 1, I get 0 minus 0. And when I go to simplify, I get a 6 on the bottom, and I get 4 minus 3 on top. And the correct answer here should be 1/6. Now, if we don't like that, you could always do this. So the area is the integral from 1 to 2 of the square root of x minus 1 minus x plus 1 dx. So this is 2/3 of x minus 1 to the 3 halves minus 1/2 x squared plus x from 1 to 2. And I claim you're going to get the same thing, okay? So this is 2/3. If I plug in 2 for x, I'm going to get 1 minus 2 plus 2, okay? Because 2 squared is 4, half of 4 is 2. And I'm going to go minus, plug in 1 for x, I get 0, minus 1/2 plus 1. And so this is 2/3. The 2's canceled, right? 1 minus 1/2 is 1/2, right? And then I'm subtracting 1/2. And notice how the correct answer here is still 1/6. So it works out the same way. Okay, that'll do it for this video. This is the Exam 1 review, Chapter 6 review, and we looked at problems 1, 2, and 3. Thank you.